Thank you. I'm just gonna pour up some water because I realized I'm not very used to talking in crowds anymore, so my voice almost disappeared. Okay, cool. So yeah, my name is Sebastian Nabrink, and I'm from a company called Oterlu. And we develop services that helps different social communities such as games or social medias or commenting systems or whatever to identify different bad behaviors such as you mentioned, hate, but also general harassments or inappropriate language in general. So first of all, this is me. So I'm one of the co-founders, and whenever someone asks me what I'm doing, I usually say that I'm like a technology generalist because I don't really have a specialty. I work for everything from developing backend systems to machine learning models to like infrastructure. Maybe not front end or design though. I'm not really allowed near that, but the other things I do. So a little short introduction about Oterlu. So we are a very small startup. We are 3 co-founders. We were founded in Gothenburg in 2019. And I joined the team in 2020, which was probably right after COVID started. So I would say that we are definitely like a COVID company. We have an office, but we have been working remote since start, essentially. So that's kind of our day-to-day life right now. So within the team, we are a mix of both technical but also domain knowledge, because trust and safety, which the area is called, is pretty specific. And one of our co-founders, he used to work at Google for 8 years with specifically trust and safety, and more specifically around children's safety. So he is a really good asset in this. And then we also have, we are a total of 5 people in the company, so we are still a fairly early stage startup, I would say. And we also have a guy in the team who is used to working with Discord communities, for example. For those who are not familiar with Discord, it's like a chat platform for gamers that has been emerging to different areas. I'm going to talk a little bit more about that later. Also within the company, we have about 10 plus years of AI expertise. I've been working as a data scientist previously. Even though I have a background as a developer, which is kind of my main background, which I always bring into my machine learning work as well. And I think that will be a little bit more obvious later on when I talk about those things. Also, it's going to be a little bit technical because I'm going to go into some details about machine learning, specifically neural networks. But I'm going to try to keep it as high level as possible for those who don't really like those parts. In general, we do live moderation today for about I don't know, several million messages every week. So you can kind of have a feeling for the scale. And that is for everything from social platforms, such as different chatting platforms, to online games and also news platforms. So the Oterlu Services consists of 3 different main parts. We have an asynchronous API, which is sort of designed for being robust. So this is how the customer integrates with us. They are sending messages through different APIs. We classify the message and send back in some way. And this asynchronous way is that they send a message to us, but they don't expect the answer to come immediately because it's not important for them. It's more, they want the answer at some point in time, either for doing analysis retroactively or it's not as real-time demanding. And this API is the preferred way because it's pretty cheap to run, and it's also very robust because whenever a message comes to us, they can almost always assume that it comes back through a webhook to their services. We also have a low latency API, which is designed for these near real-time applications, such as in-game chat, for example. I mean, if you're writing a message and it takes 2 seconds for the message to go forward, you are a bit annoyed, you will notice. So we try to keep the latency as low as possible. And this is one of the biggest challenges we have, actually. And I'm going to go into more about that as well. A lot of teasers, I feel. And then lastly, we have a Discord bot, which is in the Discord platform, there's a possibility to create these bots that goes into your Discord server and kind of monitors the different channels where people talk to each other. And the Discord communities can be fairly large, some of them with like 500,000 members or something. So and usually most of the moderators in these communities, they are doing this on their spare time, sort of, which makes it really, really hard for them because there's so many million messages all the time. We act as a filter. We don't remove anything. We just send the message to a separate channel and show them that this message was written and it was pretty bad, so you should probably check it out. But the point of this talk is not about the different services, it's about the custom AI models, which is kind of the core of our whole system. So what I'm going to do is I'm going to go through like more of tips and tricks of how we solve these problems, because deep learning is pretty computationally heavy. And it's fairly expensive to run. And as a startup, we don't really have a lot of money. Which is the part I like, we have the constraint of we need to make things as cheap as possible, but still keeping up with the accuracy demands of our customers and also the latency demands. So for those of you who work with machine learning, this is probably very common workflow. I think I've seen this mentioned several times today in different talks, that we have 3 different parts. One is the data part, which I would say is our most important part and where we put the most effort. And then we have the model training, which is everything around training these large models. And also the deployment, which is where the models actually are put into production and being run on a daily basis. So I'm going to start with the data part. So one of the things that I also actually saw, I think it was Oterlu who talked about the data and talking about smaller or higher quality data sets can usually perform better than larger data sets with some noise in. And this is very true. This is something we realized along the way, which is very fortunate because we are a small team and we don't really have the resources to actually outsource the annotations. So we have to do a lot of annotations internally in our team. But we learned pretty quickly on that if we start focusing on the quality of the data, so we keep the data sets pretty small, but we'll put a lot of effort in to make sure that we remove every sort of mistake. Because if there's a huge data set, the amounts of mistakes are going to increase. People always make mistakes, and that's fine, that happens. But if you have a lot of these, especially if you have contradictions in the data set, you start seeing very, very strange behaviors in the end result of the models. Also, as I mentioned, the annotations are all done internally. But we do also sort of crowdsource because we are working very closely with our customers. And the customers, they provide a lot of feedback for us, especially when they find things they don't like. They notice some false positives, some false negatives, for example. They always report that back to us. So we have this continuous communication with them. But we also built sort of a community around our services, and more specifically around the Discord bot, but also one of our APIs, which is open and free to use. And there we have people hanging out and just helping us find these weird behaviors of the models, which really helps us increase the data sets as well. So that is super important. Also, the model behavior in mind is a kind of a weird topic, but so sometimes when you have some data points, for example, we have a mistake. An example is that our model suddenly started marking squirrels as toxic for some reason. And we were very confused about this. It's like, why squirrels? And we started going through the data, and then we realized that we only have one squirrel, the word squirrel, in the data set, and it's a person harassing someone else using the word squirrel for some reason. And the model thought that's nice, then I will just use this squirrel as toxic. Those are things that are very hard to find. So you need to be very careful in how the data is set up so you don't have these small weird behaviors but that is also back to the feedback because that's how we kind of notice these things. Let's see if I didn't follow my path. I never do. Okay, so then we have the model training, which is, I think is sort of my baby. And so first, I'm going to start off with a little bit of a context because, as I mentioned earlier, so we are working with natural language processing because we're doing text data. And text data are usually pretty complex data, very high dimensional, very diverse, and so the only area that actually start giving some tractions for an NLP is deep learning and specifically transformer models. And I think you all heard a lot about these like GPT-3 models. They're just getting bigger and bigger. Some of them have like billions and billions of parameters, and all these parameters had to be somehow tuned towards your data set, which is an extremely expensive and computationally heavy process. So then that's the first case we encountered, like how do we actually get these pretty large, very complex models to a reasonable price and a reasonable size as well to actually work in production and for us as a company. So one of the things we learned is that we only use GPUs when they are needed. So if you look at GPUs, they are pretty expensive to run. These models, some of them even so large that they don't even fit in a single GPU, which is problematic. These larger models like GPT-3 is very, very slow, even on GPUs or TPUs for that matter, which is a more of a specific hardware for running these types of models. So the first thing we kind of look into is how can we optimize and use the GPUs only when we need to. So I took the liberty to hand draw my own neural network. I don't know if it's a good idea, but I wanted our colors. So if you look at this neural network here, let's see if I can show a little bit here. So when you train these large models, you usually have these larger pre-trained models. And these, because these models cost a lot of money, millions of dollars to train, takes weeks up to months to train. So you can't really start from scratch. And so the base, you always start with the model that has some sort of general knowledge, sort of, about language. So they are trained on language and trying to guess, for example, missing words in a sentence is one way to train them. But fortunately for us and for any other company who works with this is that there are big companies that do this for you. And they pre-train these models and then they release them for free for many different languages, which is also very fortunate for us. So what you do then is you take these big models and then you start training these models on your own data sets. In our case, so for example, you want the model to understand the language not only for what has been seen on like Wikipedia or Reddit or in books or whatever. You want the language model to understand the language within your specific community. So one case is, for example, you have a game where you are running around and shooting at each other, for example. Language is going to be one way, and then you look at the cat community. And I think the language is going to be very different there. So that's the first step. So I will refer to this part as the original language model. So this is the base. And then the next part is, because then you also want this model to be able to identify some sort of behavior. So you need to convert it into a classifier. And then you use something called transfer learning. For those of you who are not familiar with that, is that you take a big model, you run your data through it, and then you add another classifier or another smaller model at the end. And this model, and then you train your model on this. And there are different ways of doing it. One way is that you train using backpropagation through the whole model, altering every parameter. That's the way that gives the best accuracy. I wouldn't prefer that way because it also requires you to go through the whole model every time, which is very expensive. Also, it tends, anecdotally though, to be a little bit more lazy. It kind of only looks at specific words more than actually looking at the whole sentence. So what we did is that we actually started treating this part as a pre-processing only, which means we take our data set, we run it through this whole thing once, and then you have a data set prepared. And then you just use that data set and train it on this small classifier, which is a very small model. And it's so small you can run it on a CPU. I even train these models on my laptop, and it takes several minutes only, which means I can really fine-tune these hyperparameters to get the model to perform very, very well. And then the last part is just that we use a service called AWS Batch, which just helps us kind of do this at scale in a better way whenever we use the GPUs. But I'm going to skip that because it's not very interesting for this talk. Also, whenever we have something in production, we actually use CPUs as well. I see you kind of start seeing a theme here now that the CPU is king for us. CPUs are very, very cheap compared to the GPUs, and they don't. In this case, they provide some performance, the GPUs, But we have some other tricks, like we tend to use smaller models in general. Smaller models usually perform a little bit worse, but we can compensate that by having very high quality data sets, which makes it a lot more performant and behave the way we want anyway. So it kind of works using these smaller models anyway. We haven't seen a lot of accuracy benefit actually from going larger, only that they go slower. And another thing, we use something called ONNX, which is a Microsoft developed runtime for converting your neural network or machine learning model into intermediary format, sort of, where they can do optimization. And what this gives us is, I always forget this, that they give us that we can run it everywhere. We don't need to rely on Python, for example, which we run a lot of our services in. And also, it actually gives us a certain CPU boost because this ONNX environment helps us utilize some different instructions for the CPU, more specifically for certain Intel CPUs. So this actually gives us, in the end, we don't really have that much slower speed compared to the GPUs. I mean, we even have say 40 millisecond on average for our requests, which is pretty low still, even though we don't use the GPU. And lastly, we use something called AWS Spot instances. And that's actually a part that I didn't mention because I skipped the batch part, but we use something called Spot instances, which is a service in AWS where you can use unused capacity to a fraction of the cost. And because, for example, the models, when we train them, since we spend so little time on a GPU, we actually have time to wait for this capacity to be available, which makes it very easy for us. So we use them all the time. And in production, for example, when we deploy our services, the cost is very low, but the downside is that this capacity can be removed from us at any time. So what we need to do then is it kind of has a nice side effect that we have to be prepared that any service can be removed at any time, which is pretty good because that means we create robust systems by default. And I think that is it, actually. So as just the last thing, I just want to, if you're any curious about what we're doing and want to try our services, you can just try our Discord bot, which is available at this address here. You can also sign up to our API if you want to use it. Or if you're just excited about what we're doing or curious or looking for some interesting work, I suggest you reach out to either me or to this more generic address. Thank you.
Thank you. Thank you, Sebastian. Very interesting to see how you manage these models.
Thank you.
Are there any questions?
Hey, thank you for your presentation. It was really interesting. My question is, we hear a lot of big companies, some of the biggest, like Facebook, for example,
Yep.
when they were in front of Congress, they were, I don't want to say attacked, but they were accused of not fighting hate speech and misinformation. And some of the aspects that they talked about was that it was difficult to fight on different languages.
Yes.
But you said that that could be circumvented in your bot or like your solution. My question is, why big companies like this with basically infinite resources still fail at fighting like hate speech when we see startups like this doing like such a good job?
That is a really good question. So yeah, I mean, it is true that it is a very, very tricky problem. It's very hard to solve. And I think when Facebook talks about this, it's usually because they have such a diverse community and they have every type of person, every type of language like French and Chinese, but also languages in terms of what the community is. And for them, it's pretty hard to find a solution that can solve all these things. What we do is we are very specific and we work very closely with the specific communities, which means we can learn their language, their way of talking. We also know pretty well what different languages they speak within the community, which means we can also create models specifically for that. Also, we get all this feedback from the customers all the time, helping us to actually fine-tune and get these models better. Fortunately, though, actually most communities still are very English-heavy, which is good because you can still catch a majority of the problem. But I mean, yeah, there will always be these like shadows of pieces of information that is hard to get, but we do our best to get there, and I think it will take some time. But being specific helps, I would say.
Thank you.
Thank you.
Right. Thanks. And if you have any more questions, just grab
I'll
him
be
by.
around.
We have the networking or the hangout afterwards. Hopefully you'll stay on
I
for
will
that.
stay. Yes.
Yep.
Yes.
Okay. So we have a little bit shorter time this afternoon. So, but big thanks.
Thank you.